We're going to be starting our next topic, equations now. Now just a reminder of the terminology. First point here says an equation is any algebraic expression with an equal sign in it. So this here would be an equation. But if we didn't have this first portion here, we just had 2x plus 2, that would only be an expression. So the fact that it has an equal sign in there is what makes it an equation. The letters or pronumerals that we have are just standing for a number. And the point of solving an equation is determining what that number is. An important thing that you need to be able to do is to be able to see if a solution is true. And to be able to do that, there's a very particular format that I'd like you to do this in. The reason why I'm teaching this to you now is because I know later on in your mathematics careers, you may be asked to do something called a formal mathematical proof. And to be able to do that, this is the format that you use. So let's look at this first example here. It asks, is x equals 2 a solution to this equation here? Now, to be able to do this, this is the format I want you to follow. First off, we need to look at our equation and identify the left-hand side and the right-hand side. You might need to think about your lefts and rights, which I know sometimes I confuse. So, LHS is the way we write left-hand side for short, and this side here, that's the right-hand side. So let's write RHS. In order for x equals 2 to be a solution to this equation, that must mean if we substitute in x equals 2 into the left-hand side, and separately substitute x equals 2 into the right-hand side, they must both be equal. So whatever we get for the left-hand side must be equal to whatever we get for the right-hand side. So this is how I'd like you to lay it out. First off, let's write LHS for left-hand side, and let's write down what that was, 3x plus 2. Now, we're going to substitute. So let's make a note for our future selves. We're going to substitute x equals 2 into the left-hand side of the equation. So that means we're going to have 3, and instead of x, we're going to have 2. So 3 times 2 plus 1. Oops, plus 2, sorry. So that's going to be 8. Okay. Now, separately, I'm very fussy about this because I want you to form good habits just in case you do specialist maths in year 11. It's a really good subject. So, on the right-hand side, that was 7x minus 6. Now, let's substitute in x equals 2. We've got 7 times 2 is 14 minus 6. And that, really brilliantly, also gives us 8. So this is where we know, great, the answer we got for the left-hand side was equal to the answer we got for the right-hand side. So now we get to write a lovely statement. Left-hand side equals right-hand side. X equals 2 is a solution. If we had found the left-hand side and right-hand side were equal to different numbers, that must mean that x equals 2 was not a solution. So let's see what happens for the next example. Let's set it up just like we did before. This is the left-hand side of the equation, and this is the right-hand side of the equation. So the left-hand side equals 4x minus 4. Now we're going to replace that x with a minus 3. So now we've got, thinking of BIDMAS, 4 times negative 3 is negative 12, minus 4 is going to be negative 16. Okay, we don't know whether this is a solution yet because separately, and I sometimes even tell students to put a line in between their left-hand side and right-hand side so they're not tempted to smush them together. So we need to see what the right-hand side is equal to. So 7x plus 4. Now 7 times negative 3, because we've substituted, plus 4. That's going to be negative 21 plus 4. Negative 21 plus 4, negative 17. Oh no. So now we've seen the left-hand side was equal to negative 16. The right-hand side was equal to negative 17. So now let's be really clever. We're going to write left-hand side, and we want to write does not equal. You can represent that by an equal sign with a line through it. Really handy. So left-hand side does not equal right-hand side. So x equals negative 3 is not a solution. So, recapping what we did there, we set out what the left-hand side and the right-hand side was equal to when we substituted in the value that we were interested in to see if it was a solution. If the left-hand side equaled the right-hand side, then yes, it is a solution, like the first example we had, A. And in the second example, B, we found that the left-hand side did not equal the right-hand side after we substituted, so that meant it's not a solution. Another important skill that you're going to need to be able to do is to write equations when you're given a sentence or a described mathematical situation. We're told a number n is added to 1. So, if we want to start writing our equation here, a number n is added to 1. Now, we're told it's divided by 5. If we just wrote divided by 5, BidMaths tells us that it would only be impacting that 1 there. So to represent the entire thing is divided by 5, what you could do is put brackets around it, or you could recognise that dividing by 5 could also be written by this whole thing divided by 5. Remember, division signs are just fractions in disguise. So I always prefer we write that as a fraction. So we've added 1 and we divided by 5. We're then told that 6 is then added to this result. Okay, plus 6, and it gives a result of 1. So when we take this number, add 1, divide the whole thing by 5 and add 6, the result, so that must mean this must equal 1. Now, for this, we're only writing the equations. We're not actually finding out what that number is. Don't worry, we're going to do plenty of those later on. So let's do the next question. A number n is added to 2. Okay, n is added to 2. We're then told, so we've done that, it's tripled. So to make the whole thing be tripled, we're going to break out our wonderful bracket friends and put a 3 in front, because that means 3 times the entire thing, n plus 2. We're then told this is all divided by 5. So let's do a big old vinculum, 5. 4 is then subtracted from this number. So now we need to take away 4. And this gives a result. Oops, I realize I haven't been. There we go, tripled, divided by 5. 4 is then subtracted, and we get a result of 2 equals 2. So that's how we'd write an equation here. Always look out for those things like tripled or result. Sometimes those words mean we need to think about it a little more carefully. Some other words that are really important to know. Sometimes product is used. And product tells us that we're multiplying something. Quotient is also a fancy word that can be used, and that means we're dividing something. So if I said the quotient of 4 and 2, I would mean 4 divided by 2. It's usually meaning the first number, and then the second number is what we're dividing it by. So now let's get into solving some of these equations. To be able to solve, we need to remember our inverse operations. Inverse means opposite, and operations is talking about what we can do with numbers, adding, subtracting, multiplying, dividing. So the opposite of adding is subtracting. They're opposites. And the opposite of multiplying is dividing. So we call these inverse operations. So I like to remember adding and subtracting are inverse operations, multiplying and dividing are inverse operations. I wonder if you can remember any other inverse operations that we've done this year. I like to remember that raising something to the power of 2, I should say. The opposite or inverse operation to that is taking the square root of something. So the next title says we're going to be solving equations using formal algebraic setting out. Really, really important to show your lines of logic here. So let's do that. In this first equation here, we've got 2x plus 7 equals 17. Now, to be able to solve this, we need to think of inverse operations. And I want you to think about what operation we're going to do first. I see that we've got x, and to build this equation here, just like we were doing before, we had x, it was multiplied by 2, and then we added 7. So, to strip that back to just having x, we're going to have to subtract 7 from both sides. I like to have a column on this side here. I don't really put a line or anything, but I call it the action column. And it reminds me what I'm going to do to both sides of this equation. So, to be able to get that x by itself, the first thing we need to do to both sides of the equation is we're going to subtract 7. So I put that in my action column to remind me what I'm doing to both sides. On the left-hand side of our equation, if we subtract 7, then we're just going to have 2x. And on the right-hand side of the equation, we must do the same thing. I like to imagine an equation as a set of scales. If I take 7 away from one side, then this side suddenly will be much lighter. So I need to take 7 away from the other side as well to keep everything in balance. So taking 7 away means we'll get 10. Now, to get that x, we've got 2 times x, and we need to think, what is the inverse operation of multiplying by 2? It's going to be dividing by 2, so we do that to both sides. X is going to be 5. If you just wrote the answer, if you just told me x is 5, unfortunately you haven't demonstrated your logic, and I need to see that on the page to be able to award you for it. Unfortunately, that's just how it works. When you're doing exams in year 11 and 12, if you don't show you're working out, you don't get those marks. So might as well write it down, because you've already done all that work. Next question now. We've got 40 minus 3x equals 22. So let's zoom in on the pronumeral. We've got x. What happened next to build the left-hand side of this equation? That x was multiplied by negative 3. And then 40 must have been added. It's like a plus 40 at the front there, but we don't write the plus when it's a number at the front by itself. So to solve this equation, we're going to start off by subtracting 40 from both sides. On the left-hand side, this will leave us with minus 3x equals, and then we're going to have 22 minus 40. That's going to be minus 18. This is where people often get a little bit stumped. They see we've got minus 3 times x. We need to think, what's the inverse operation of multiplying by negative 3? So if we're multiplying by negative 3, the inverse operation must be, I nearly said the wrong thing, it must be dividing by negative 3. So we're dividing by negative 3 here. So if we do that, on the left-hand side of the equation, negative 3x divided by negative 3 just leaves us with x. Great, that's the purpose of what we're trying to do here, get x by itself. Negative 18 divided by negative 3, if we think about signs, we're going to have a positive, and 18 divided by 3 is going to be 6. Another important feature of our equations is we want to end up with our pronumeral on the left-hand side by itself. So if you had solved this equation and you'd ended up with like x on this side and 6 on this side, it's good if you just, flip it around in your final answer. And you'll see that in some other questions we'll do later. Okay, next one here. I want you to think, which inverse operation are we going to do first? Are we going to subtract 2? Are we going to multiply by 3? Or are we going to divide by 4? My preferred thing with this equation here is to subtract 2 first. So that means we get 4x on 3 equals, my vinculum disappeared there, 4x on 3 will be 12. Then I want to multiply by 3. So 4x is going to be 36, and then divide by 4. X will be 9. If you're interested, we can discuss some other ways you could solve that problem. So long as you do things carefully, you will get the same answer. We now have an x, and to build the left-hand side of the equation, I often think about how did I build it so that I can unpack it again. So we started with an x, we multiplied by 4, we added 2, and then we divided by 3. So to unwrap this, to get back to x again, we're going to multiply both sides by 3. So on the left-hand side, multiplying by 3 undoes the divide by 3, so we're going to have 4x plus 2. And then multiplying the other side by 3, we're going to have 42. Oh, one thing that I forgot to mention, and you might have noticed that I've been trying to do this. So I'm going to go back a step. I want you to make sure you're lining up your equal signs. That's really important. Sorry, I meant to mention that earlier. Now, for this question here, I've started off slightly over here because it would be hard for me, because my handwriting is much larger than text, to line it up with the question above. But that's okay. So long as all of my equal signs from now on are all lined up, I think that's fine. Now, we're going to take 2 away from both sides. So that will give us 4x equals 40. And then when we divide by 4, x will be 10. Nice. You've got a few options about what you might do here. You might like to do this slightly differently to how I'm going to show you, but I'm just going to show you what I like to do. So basically, all of the questions we've had so far, we've had, and the one that we'll do later on, we've had the variable on the left-hand side. I notice on this question, it's on the right-hand side. What I'm going to do is I'm just going to take this right-hand side and move it to the left. I'm going to take the left-hand side and move it to the right. So that would literally just look like 7 minus 2x on 3 equals 5. We're going to take 7 away from both sides. So minus 2x over 3 equals 5. We've got that negative sign here. That negative sign, I'm just going to talk here for a moment, is currently written at the front of the 2x minus 3. You have a few options about this. You can either say that negative, let's just pop it onto the numerator now, or you can say that negative belongs to the denominator. I always prefer to put it with the numerator. I don't know why. It's just how my brain kind of works. But the problem is you can't do it with both. You can't say, oh, let's give a negative to the top and a negative to the bottom, because a negative divided by a negative, that cancels out to become a positive. Now, that's not what our equation was. Our equation was negative and then 2x over 3. So decide. Put it on the top or put it on the bottom. I'm going to be saying it belongs to the top. So that means on the bottom, we just have positive 3. And we're dividing by positive 3, so we're going to multiply it by positive 3. That means we'll have minus 2x, because we undid that divided by 3, will equal 5 times 3 is 15. Now we've got negative 2 times x. The inverse operation will be dividing by negative 2. So x is going to be, we now have 15 divided by negative 2. There's a few ways you could leave this question. I like improper fractions, so you could write that as negative at the front, 15 over 2, mainly because we prefer the negative to not end up on the denominator of our fraction. You could write it as a mixed number, or you could write that as negative 7.5. This is my preferred answer. Final question here. Have a look at what we've got. I'm going to start off by multiplying both sides by 4, so we can get rid of that denominator. That will mean on the left-hand side we have negative x plus 3 equals 24. Let's subtract 3 from both sides. Now we've got minus x equals 21. Now, a lot of people stop here, but the problem is we don't have x by itself. We've got minus x. And what that technically is an x with an invisible negative 1 attached to it. Now, there's multiple ways you can think of to get rid of this negative 1. I like to think about dividing by negative 1, because that's the inverse operation to multiplying by negative 1. So x will equal, negative 21. Dividing by negative 1, it just changes the signs. So our negative x became positive x, and our positive 21 became negative 21.